I want us to look at this subtopic under algebra called the exponents and surds. Look at November 2014, it was question 1.1.3. Usually it's about 3 marks. Let's work it out. You've got 2 to the power x plus 2 plus 2 to the power x is equals to 20. The question is, of course, solve for x. Find the value of x. How do I go about? Remember, it's question 1. Use your eyes. When you look at this, I can see what we refer to it as a common factor, 2 to the power x. In fact, if you go back to exponential laws, if we've got 2 to the power x plus 2, before this, it was in this form. It was 2 to the power x times 2 to the power 2 plus 2 to the power x is equals to 20. Now the problem is, this one is not 2 to the power something. If it was like that, it would have been easier, because if the bases are the same, then the exponent would have been the same. But now, when I look at this, how do I go about solving this? I use my eyes. How many terms do we have on the left-hand side? We've got only 2. This term and this term. It is equal to something. Now, when I look at this term and this term, what do I notice? I notice something which is the same. We refer to it as a common factor. I see a 2 to the power x, and I also see another one here. If I take it out, we refer to that as a common factor. So we're going to have 2 to the power x into. If I take it out, what am I left with here? I'm left with 2 to the power 2. 2 to the power 2 plus 2 to the power x times what will give me that? Times 1. This is equals to 20. That's what I have. What do I do next? Remember that I'm solving for x. I've got to leave that one there. So this must go. What is this in actual fact? What is 2 to the power 2? It is 4. What is 4 plus 1? It is 5. So we divide by 5 on both sides. So that this 5 divides here once. We are left with 2 to the power x equals to 5 into 20. 5, 10, 15, 20. Goes 4 times. But can I write 4 in this way? I'm just working on having the bases the same or the exponent the same. The rule says, if what you are looking for is an exponent, like in this particular case, you are working on making the bases the same. But if what you are looking for is here is the base, you must try and make the exponents the same. So in this particular case, we're trying to make these bases the same. Can I change 4 to be the same as 2? Yes, I can. So what do I have? I've got 2 to the power x as the same as, can I change that into 2 to the power something? Yes, I can do that. 4 is the same as 2 to the power 2. This is where I wanted to come. If the bases are the same, therefore the exponents will be the same. Therefore this means that x is the same as 2, because the bases are also the same. That's how you go about solving these ones. In fact, it involves the factorization, taking out a common factor. That's part of your first part of algebra, which is factorization. I want us to look at the next one. Slightly different. It was taken from March 2014. It was the supplemental exam. It was question 1.1.3. About 3 marks as well. Same challenge. We're looking for x. We're looking for x. Remember before it was like this, how it was. The challenge now, the x is on this side, it's also on that side. I've got to clean it such that I've got x equals to something. Let's work it out. 3 squared, I see 3 squared. Let's just work it out. I've got 9x, okay. I've got 9 times 2 to the power x times 2 to the power minus 1. Remember, this is 2 to the power minus 1, which is the same as half. 2 to the power minus 1 is the same as 1 over 2. I can write it like this or like that one, is one and the same thing. This is equals to 2 times 3 to the power x. Okay. You know what is our challenge at the moment? We've got these x's on both places. How do I clean it such that it goes to one position? There are so many options. Let's try and take the easier option. This is 9.5. This is 9 over 2. So this side I can divide by 9 over 2. 9 over 2, which is 9.5. What I do this side, I've got to do on the other side. I divide by 9.5 as well, 9 over 2. Right, so this will go with both those two. I'll be left with 2 to the power x, right? Now we still have the same problem. I do have 2 to the power x here, and I also have it on the other side. Let's write what we have. We now have 2 to the power x is equals to 2 times 3 to the power x all over 9 over 2. That's what we have. Now I want us to take this a step further. I want us to divide both sides by 3 to the power x, because I want to bring this one this side. If I divide this by 3 to the power x, I will be left with 2 to the power x divided by 3 to the power x equals to this 2 times what? Divided by this 9 over 2. 9 over 2. That's what I have. I'm just working it algebraically. Right, let me just clean this. This is 2 to the power x over 3 to the power x as equals to, change the sign, this will be 2 times 2 over 9. Change that multiplication sign, that into multiplication sign, you swap it around. So we've got 2 to the power x over 3 to the power x, which will eventually give us what? What is 2 times 2? It is 4 over 9. That's what we have. We still have the same challenge. We still have 2 x's, which must try and make 1 x. Now watch here. Oh, I got it. We've got 2 to the power x divided by 3 to the power x. This 2 is to the power x, and this 3 is to the power x. In other words, both 2 and 3 are to the power x. That's what we wanted. We wanted to have 1x. So we're saying 2 and 3 are both to the power x. Remember, our x in this particular case is the exponent. So what is it that we must try and do? We must try and make the bases the same. We've got this to the power x. In other words, this base is 2 over 3. Can we make that to be 2 over 3? Yes, we can. We can't get 2 here, we can get 3 here. What is this? This is 2 to the power 2 over, this is 3 to the power 2. 2 is to the power 2 and 3 is to the power 2. We can write it in this form. Both of them are to the power 2. Are the bases the same? Yes, our bases are now the same. Therefore, the exponents are also the same. Therefore, x is equal to, since the bases are the same, therefore the exponents are the same. Therefore, x is equals to 2. This is how you go about solving this kind of problems. There are so many methods you can try and solve it, but you must come to the same answer. Let's look at the last one. Simplify without the use of a calculator. This is now, I involve surds. This signs here, we call them surds. Involved a square root, no cube root, we call surds. Simplify without use of a calculator. All right, this is what we have. We need to simplify this without the use of a calculator. Matriculants, whenever you see surds, think of perfect square at the back of your mind. Do you know what is a perfect square? The smallest perfect square that we have is 1. The next perfect square after 1 is 4. After 4 is 9. How do you find perfect squares? Let's work them out here. 1 times 1 is 1. So 1 is a perfect square. What is a perfect square? It is a number out of square root size remainder. The next perfect square after 1, it will be 4. How did you find 4? It's 2 times 2. The next one after 4 is 9. How do you find 9? It's 3 times 3. Square root of 9 is 3. Square root of 4 is 2. Square root of 1 is 1. So these numbers are perfect squares. They are many. 4 times 4 is 16. After 16, it's 25. After 25, it's 36, 49, 81, and so on and so forth. You must know these perfect squares from 1 times 1 up to 25 times 25, because those are the values that we use at your level. Now think of perfect squares. Whenever you see such, think of perfect squares. Why do you have to think of perfect squares? Because it says without the use of a calculator. Without the use of a calculator. I can't solve this. I can solve this square root 3 times square root 3. What is square root 3 times square root 3? It is 3. I can't do this without a calculator. So that's why I said you must think of perfect squares. I've got root 3 here, I've got 48 there. I said think of perfect squares. I can't solve this without a calculator. So at the back of my mind, I should understand that I must have another root 3 here and a perfect square. Because once I have a perfect square, if I've got a square root of 4, I know that it will be 2. A square root of 9, it will be 3. A square root of 16, I can't find that without using a calculator. Can I break this number such that there is a perfect square and a 3? Let's work it out. I want us to break this value here. I've got root 3, this is equals to root 3 times r. Can we break 48 such that there is a perfect square and a 3? 3 times what will give us 48? 3 times what? Let me quickly check. 48 divided by 3, 48 divided by 3. Yes, 3 times 16. 3 times 16, this is exactly the same as that one. But, is this a perfect square? Yes, we can find it without a calculator. Therefore, you'll always have a situation like this one. When you break it, you must break it such that if this was 2, I must have 2 times a perfect square for me to be able to solve it. Let me go to the other side. It's minus. Remember this before it was this? It was 4 to the power x times 4 to the power 1. Because the rule says, if you multiply powers with the same base, you add the exponent. That's where x plus 1 comes from. It comes from the rule. When you multiply powers with the same base, you add the exponents. Right. Since I've made it 4, I could have made it 2 to the power something, 2 to the power something, because I see a 2 here. Or if I go with 4s, I must make this 4 as well. I can see the 4 here. 2 to the power 2, it is 4, and there is x next to it. It is one and the same thing. Let's do this thing. So this is in actual fact the same as root 3 times root 3 times root 16. This side, it's minus. You can see that to this one, and that one, it's 1. So it's minus 4 to the power 1, which is 4. That's what we have. We're trying to simplify. We're responding to this without using a calculator. What is root 3 times root 3? We've talked about it here. Root 3 times root 3, it is equals to 3. So this is actually giving me 3. What is the square root of 16? Remember, how do you find 16? It's 4 times 4. Square root of 9 is 3. Square root of 4 is 2. Square root of 16 is 4. So in this case, square root of 16, I can do it without using a calculator. Perfect square. So it is 4 minus 4. What is 3 times 4? It is 12. What is 12 minus 4? It is 8. That's how you go about simplifying the surds. And actual fact, the key here was to think of breaking this such that there is a perfect square and the same value as this one, so that I'll be able to multiply this and find a solution like this one and be able to deal with the perfect square to get the solid answer. Thank you.